Never mind, I'll find someone like you. I wish nothing but the best for you. Don't forget me, I beg. I remember you say sometimes it lasts in love, but sometimes it hurts instead.
Your next trig functions lesson, transforming trig functions. Make sure you have, well, hopefully you've watched the first lesson. And at the very end, I gave you the key points to sine and cosine. Make sure you have those in front of you for when we start to get into the graphs. It'll just help you be able to make those graphs as we transform them. Our learning goals. We are going to recall transformation notation. We've already done it a few times now. We're going to look at A, K, D, and C to transform sine and cosine. And then we're going to look at some patterns and some meanings behind A, K, C, and D and how they relate back to our trigonometric graphs, sine and cosine. Now, if you're wondering, there is a graph for tan. However, you don't do tan until grade 12. So we're just going to focus on sine and cosine. First thing we are going to do is review our general transformation notation. The first thing, you're going to see things like this. So y equals a. Now it could be sine or cosine. So I'm just going to say sine k x minus d plus e. And it could be cos instead of sine. But that's where all the parameters go, just like they've gone for all the other functions. Our txy, actually, well, before we get into that, we'll just quickly go over what each of these values does as a quick review. So you have to recall A. What does A do? A controls your vertical stretch or compression. If it's negative, it's reflected in the x-axis. And when it comes to our trig functions, a pattern that holds, A actually gives you your amplitude. And remember, amplitude is always positive. Even if that's a negative out front, that just means it's reflected, but amplitude is a distance, so remember it is always positive. K, what does K do? It does the opposite. It does horizontal stretch or compression. It also can control a reflection in the y-axis. And there's not necessarily a special pattern when it comes to trig with the K value. However, the K value is involved in a formula that we're going to use. P for period. Remember, the period of sine and cosine is 360. So P equals 360 degrees divided by K. What does the D value do? Shifts left, right. So I'm just going to write left and right. This actually doesn't have any kind of special information or any special formula relating to our trig functions. And C shifts up or down. C also gives you the equation of axis, EOA, equation of axis. Remember, that's our max plus our min divided by 2. So there's our general function notation for a trig function, along with a lot of review plus some new things and how it pertains to trig. We're going to go over txy again here. So remember txy is x over k minus d and ay plus c. Remember, x is always opposite to how it appears in the function. So if it's a whole number as k, it's divided by k. If it looks like minus d, it's plus c, and vice versa. Some quick warm-ups. Describe the transformations for each. These are literally 1-point descriptions. That 4, that is your c value. What does that do? Shifts up or down? Shifts up 4. And the goal of this is to get you envisioning in your head what's going on with these graphs. So remember I will just do quick fire graphs here. If you're looking at your lesson from yesterday, the very last slide, the sine function and cosine function, this is just moved up 4. So it would look like that, more or less, moved up 4. B, 4 sine x, that is your a value, vertically stretched by 4. So imagine putting your hands together and moving one up and one down. It's stretching an elastic. What would that look like? It would look like this, stretched up, stretched down, and back. C, sine 4x, that is your k value. Remember, the parameters that affect x are opposite. So what's the opposite of multiplying by 4? Dividing by 4. So this is a horizontal compression of 1/4. What does that do? Well, instead of moving your hands up and down, move your hands left and right. It squishes, so hold your hands out, bring them together, it squishes it in by 1/4. What would that look like? Well, it'd be just really squished horizontally. D, f of x equals negative sine x. So still our a value, but it's not being stretched or compressed, it's just reflected in the x-axis. And for sine, what does that look like? Well, instead of starting at 0 and going up, it's going to start at 0 and go down. Our last two warm-ups. I think it's our last two. E, f of x equals sine x plus 90. That is your d value. And remember, it's always opposite to how it appears. So you see plus 90, maybe you're thinking right 90, but remember, it's always opposite. What's the opposite of right? Left. So this is left 90 degrees. Then f. F, we've got 3 different things going on there. Working left to right, the first thing you see is the A. That is bigger than 1, vertically stretched. The next thing we encounter is the minus 45. That means it shifted right 45 degrees. And then the C value, minus 3. That means shifted down 3. I guess we forgot to do our graphs for E, so before we do F, we'll go do a quick sketch of E. Shifted left 90. So instead of starting at 0, it's going to start over here. And for F, it's down 3, right 45 degrees, and stretch by 5. So down 3, right 45, and stretched. So it's going to look like that, kind of. Again, our goal is just to kind of visualize. We're going to go through the TXY specifically. All right, here we go. This is the big one. This is the important one. We're going to determine the TXY. Amplitude, period, phase shift, vertical transformation, domain, range, and sketch one complete cycle. So, step number one, we're going to do the TXY and the sketching first, and then we'll answer the rest of the stuff afterwards. TXY. Make sure there's no k value attached to the x that's been factored out. In this case, it has, right? The 0.5 is outside the brackets. Now, this might mess some people up when you start, having fractions and decimals. So that's your k value, right? A, K, D, and C. You could write it as x over 0.5, but it's kind of weird to have decimals and fractions mixed together. So you kind of have to realize that 1/2, or 0.5, is 1/2, which is 1 divided by 2. What's the opposite of dividing by 2? Multiplying by 2. So really this is 2x plus 90. And if you miss that with the 2x and you just want to write x over 0.5, that is perfectly fine. I will accept that. It's not really good math form to have fractions and decimals mixed together. And then 3y plus 2. We are doing a sine function, so we need to come up with our parent points for sine. That is on your last slide, the last thing we ended off with last lesson. 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. Now, if you want to practice your calculator and transformation skills, I would say at this point, pause the video, put those 5 parent points through the transformations, then come back and check your work. If you tried these on your own, you should have got 90 and 2, 270 and 5, 450 and 2, 630 and negative 1, and 810 and 2. If you got all 5 of those, awesome. Give yourself a left-handed pat on the back. Now, coming up with our scale, once you come up with these, coming up with the scale is going to be maybe the toughest part for some people. You should take a look at your x values. So 90 is the lowest. 270, 450, 630, 810, it's going up by 180s. So based on how many lines you have on your x-axis, you got to figure out your scale. I have enough here to go up by 90s. I'm not going to write every single number because then it's going to be all squished together. So I'm going to go every other line is 180, which really means I'm going up by 90s, right? So this right here is 180, 360, 540, 720, and then 900. But remember, every one in between is really going up by 90s. 90, 180, 270, 360, 450, 540, and so on. 630, blah, blah, blah. Then coming up with your scale for your y-axis. We go as low as negative 1, as high as 5, so we can definitely go up by 1s based off of the graph I gave you. And then plot your points. 90 and 2. 90 and 2, right there. 270 and 5, 270 and 5. 450 and 2, 630 negative 1, 810 and 2. And we only want one cycle, so we're not going to put arrows on the end. So we're just going to connect these with a smooth curve, or our best attempt at one. And there's f of x. Now, if you're thinking to yourself, that doesn't really look that different. Scaling is what matters here. So you don't have to do this. I'm just going to do it for the sake of the lesson so you can see the transformations. If I was to graph the normal sine x on this graph, this is where we would be. And that's just the normal sine x. So you can see, yeah, it's been stretched, it's been shifted right, it's been shifted up, so on and so forth. Okay, so what have we done? We did the txy. We did sketch one cycle. Now we want the amplitude. Well, the amplitude, I mean, you could use our formula max minus min divided by 2. That's great. It's just our a value. So our amplitude is just 3 right here, the a value. The period, how long does it take to complete one cycle? We could look at our graph. It goes from 90 to 810. What's that distance? You could just subtract, or we could get into the habit of using this formula, which we're going to use in the future. P equals 360 over K. What's your K value? Well, it's up here. It's 0.5. What's 360 over 0.5? 720. And if we would have done 810 minus 90, we get 720. The phase shift. The phase shift is just how far you shift right or left. As you can see, I normally start right here at 0 on the y-axis. I have shifted right, how many degrees? 90. So we'll write PS for phase shift, 90 degrees. Right. You can also get that just by looking up here at your equation at the d value. Our vertical transformation, we've shifted up 2. That's also our c value. So we'll write VT for vertical transformation, up 2. The last thing is domain and range. Domain. For any trig function, it can be any real number. Now, since we don't have arrows on this, if it was just sketch at least one cycle and you had arrows on the end, it could be any real number. However, our our graph, based on what we picked, only exists between 90 and 810. But normally for a normal sine x or a cos x, x can be any real number. So for our graph, though, x is any real number such that it has to be between 90 and 810. And those are degrees. Our range, I'll do range up here. Our graph only exists between -1 and 5 and everything in between. So y is any real number such that lowest number goes first. -1 is less than or equal to y, is less than or equal to our maximum, which is 5. And there we've done a very thorough example of all of the key information and our sketch, of course. And then our next example, determine the txy, the amplitude, the period, the phase shift, and vertical transformation, domain range, and sketch one complete cycle. This time we're doing cos. So we're going to start with our txy. Excuse me. So txy equals, remember this is our a, k, d, and c. So x over 3 minus 60 negative 2y minus 3. Your cos parent points. Take a look at those from the end of your first lesson. 0, 1, 90, 0, 180, negative 1, 270 and 0, 360 and 1. Just like the last example, I would challenge you to try to come up with the transform points on your own, pause it, and then come back and check your answers. If you did try this on your own, hopefully you get these, negative 60 and negative 5, negative 30 and negative 3, 0, negative 1, 30, negative 3, and 60, negative 5. If you got that, give yourself a right-handed pat on the back. Now our scale, if you look at your x coordinates, the lowest is negative 60, and it's going up by 30s. So what I'm actually going to do here is I'm going to change where my y-axis is. I'm going to put my y-axis here. So ignore that bold black line on the left. And we're going to say this is our y-axis. We're going to ignore that other one. That way we can get into the negatives. So this would be negative 30, negative 60. That would be negative 90. 30, 60, 90, 120, and so on and so forth, going up by 30s. Looking at our y scale, we have to go as low as negative 5 and as high as 2. Negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5. That's x, that's y. We're ready to plot our points. Negative 60 and negative 5, right there. Negative 30, negative 3, right there. 0, negative 1, right there. 30, negative 3, right there. 60, negative 5, piece of cake. We're all experts at plotting coordinates. We only want one cycle, so we are not going to draw arrows and do our best to do a little smooth curve through these. And there is our f of x. Again, you don't have to do this. I'm just going to do it for the sake of the lesson. If you're like, oh, that kind of doesn't really tell me how cosine's been transformed. Well, remember, cosine does this. 0, 1, 90, 0, 180 and negative 1. It's right there. Be back right there, 270, 0, and then back at 1 at 360 right there. So right there would be the normal cosec. So yeah, you can definitely tell it's been stretched. It's been compressed. It's been reflected. It's been shifted left. It's been shifted down. You can see that very clearly from just looking at the normal plain old cosecs. So we did our txy. We sketched one cycle. Our amplitude is just our a value, but remember, always positive. And you would get that if you use the formula max minus min divided by 2. It would always be positive, but our amplitude is 2. our period. We could look at our graph, or right from negative 60 to 60, or we can use our formula 360 over k. Our k value is 3. What's 360 divided by 3? 120. What's the distance from negative 60 all the way to 60? 120. Perfect. Our phase shift. Our phase shift is our k value, sorry, d value. It has shifted left 60 degrees. And you get that from up here. What is our vertical transformation? That's my c value down 3 units. My domain and range. Again, since we were only asked to sketch one cycle, we're going to stick to the domain that we have, which is negative 60 is less than or equal to x is less than or equal to positive 60. If we had arrows on the end, any real number. Range, my graph only lives between negative 5 and negative 1, so same idea, y is all real, such that negative 5 is less than or equal to y is less than or equal to negative 1. Domain, range, there we go. Make sure you know how to transform these functions identically to how we have done in the lessons. Remember, you using some sort of dynamic graphing software online is going to give you absolutely 0 marks. Maybe 1 if I'm feeling some sympathy for you. You need to do the TXY. You need to transform your 5 parent points. You need to plot them on your graph. You have to. That is a part of the unit curriculum and the course curriculum expectations. 100%. No spoilers, no secrets. You will have to graph at least one sine function and one cosine function on your test. I can't give you a bigger hint than that. That is it. Relatively short lesson. There's some seat work, plus I've already started assigning the review for the test. As always, check D2L for the up-to-date questions. That's all for me. Thanks for listening. Happy mathing.